Could you imagine sinking hours into a mobile game for no real benefit? Well, me neither. Today we're going to be doing some Flow3. Now, I imagine most of you probably recognise this game, or maybe you recognise Flow3 bridges, or hexes, or warps. Yes, apparently the developers created a whole series out of this shit. Essentially, all you've got to do is connect the coloured dots and fill in all the squares. As simple as that sounds, even for a 5-head like me, that can get pretty tough.
Now I'm panicking.
Don't panic.
No, I am, because I'm going to lose my job.
Now, the first problem is a pretty obvious one. We need the game. I could spend a week long cloning the game and meticulously crafting puzzles, but fuck that. I'm just going to download the game on an emulator and reckon we can do some pretty fancy visual thingy. The computer doesn't know what the fuck this is, so we need to dumb it down a bit. Into, say, a 2D array perhaps? Let's take a picture.
Nice.
For those who know computers, you know arrays are more showers than growers, and we need to know how many inches, we need to know the size of that array. Best way to do this is to basically look at a line of pixels from our screenshot, look at how many times the colour changes from black to something which isn't black, and subtract 1. And this works for any size, believe it or not. Then, we just need to see where the colours are, so we do some sort of smart maths thing to determine the centres of the squares and shoot a little laser to see the colour of that pixel, assign it a number value and add it to our array. Hope you're not a vegan, because next is the actual beef of our problem. We need to solve that array. Does SAT mean anything to you? Probably not, because I had no idea what that was until I looked it up as well. A SAT solver is a computer program which aims to solve the Boolean satisfiability problem. To use a SAT solver, we first represent the problem as a logical expression. We use variables to represent the flows and their paths on the grid. For example, F123 could represent a flow starting at cell 12 and ending at 32. We then add constraints to the logical expression based on rules of the game. For example, each cell should be occupied by exactly one flow. We encode this constraint using the logical OR operation for each cell. We also ensure that each pair of the same coloured dots are connected by adding logical AND operations to connect the corresponding variables representing the dots. We also add constraints to ensure that flows do not cross each other. This means that no two flows should share the same cell or cross each other's path. We further add constraints to ensure that all cells in the grid are filled by flows, meaning there should be no unoccupied cells. We then pass this logical expression to the SAT solver, which attempts to find an assignment of true-false values to the flow variables that satisfies all the constraints. So, when we pass our 2D array to a SAT solver, this is what we end up with. Pretty cool, right? Now we have our solution, we actually need to input it, and I'm not doing that manually, so I did some mathsy stuff. Based on the value given to each cell in my array, I can determine a path from the start to end node for each colour. So I translate that path into a series of mouse drag commands by figuring out the screen location of each grid square. And I hit execute and voila, works first time. And of course our solution works for every size grid, but sadly not those funky ones like the heart or the dick. I don't actually know if that one exists. Yeah, that's all I've got, so enjoy this little montage.